called MosaiCode, Visualizing Large-Scale Software. This is a paper that we actually presented at VidSoft 2011 last semester, and it was a lot of fun and stuff. Not sure how much experience you guys have with software visualization, but I do a little bit of a backstory. I'm gonna go with like the motivation, like kind of what motivated us to do this project, and where we went with it. So that's kind of what it is. Visualization is basically what you think it would be. I mean, pretty, shouldn't be too hard to follow, so here we go. Well, goals of MosaiCode that we tried to do is we wanted to facilitate quick navigation of large software metric data sets. We're working with an organization called ABB Incorporated. That they have all these different, they do controllers for like power grids and manufacturing machinery. And so they have all these embedded systems. It's just a huge, huge software base that they have to keep track of. And they run these metrics every night, which is like somewhere around like 60 to 80 meg text files of just like all these metrics, thousands and thousands of entries. And so quick navigation is a key idea. They want to identify hotspots in their code and code churn, kind of see like what needs the most upkeep, what's getting the most attention, and where should they put their money, and understand the system's needs as it evolves and changes. And another big goal is to communicate these needs to technical and especially non-technical personnel. One of the main things in the beginning was like we need something that we can show to a like management and say like see all that red stuff right there? That's not good. We need to put money at that. And then it's like, oh yeah, that's really red, so we need to not do that. So really easy to understand, nothing technical. Wasn't our primary goal from the beginning. Concerns with all this, if we want quick navigation, obviously it has to be speedy, to work smoothly, because the data sets are large, like I said, thousands of data points. I think something around 40,000 or 50,000 among 3 versions too. So that's like in the hundreds of thousands that we gotta maintain and manage. Flexibility, they don't only use it for, I'll talk in applications later on, they don't only use it for like the developers, they also use it for impact analysis too. So they got different kinds of data. It's not all metrics, all the same metrics, but you just plug them in. And then usability, obviously, is always a good thing, because it's not the only thing they're using. We want to try and get like a Visual Studios plugin to work with like all these other different kinds of software. So flexibility and usability are very important as well. A little bit of backstory is the CSOF visual metaphor is what we're drawing from, which is Stephen Eck's paper in 1992. He kind of developed this thing. It didn't really go anywhere, I don't think, because as far as I know, you can't really get CSOF. But this is what it looks like. The idea is that this is the entire code software system, and each line is mapped to actual code. You can go down and see the code itself. And this is colored using Tarantula tool by Jim Jones, made in 2001, where he takes the metrics and he puts them on, maps them to color. And like I said, you know, red stuff is bad. Look at it. And that's kind of like the idea there. But this is kind of like a one-dimensional thing. So we kind of wanted to extrapolate that into 2 dimensions to kind of make better use of the space. So what we do is the normalized data is color-coded and organized in the top-level containers. By top-level containers, I mean if you have a software base, then you obviously have folders with source files in them, and they go down in a hierarchical fashion. So what we do is we kind of take the top-level folders and group them, everything together that's related to that one like subsystem or whatever the folder may be. That's the flexibility part of it. It could be anything. It could be files, it could That's what we're using there. Files, methods. The entities are the tiles, which you'll see up here as squares. If you saw the posters, there are all the squares on it. That's what we use. And just like in CSOF, where you can drill down to the code level, we don't actually go all the way down to the code, but you can go into one of these top level containers and see the next level of folders and stuff. So without much further ado, this is the MosaiCode layout. You see here, we have these folders here. I think this is the one that's looking at this field buses thing. So over here in the tree view, you can see it's like a file system. You can see field buses as a components level underneath it, things like that. We generate a summary of the data itself to see like, well, this is the maximum value you can have, and these are the value divisions of whatever metrics being visualized, which right here is the average cyclomatic complexity on this one. If you haven't taken software engineering or don't know much about metrics, just don't worry about it. Cyclomatic complexity, if it's high, it's bad. This right here is an entity view that we implemented to actually see all the other different metrics. There's something like 62 different metrics in this file that I'm going to bring up later in the demo. And just general functionality. We support multiple versions up here with the kind of, Andrew Sutton called it an iTunes style playback bar. And he told me, like, we need a way to control the versions, make it iTunes style. So I was like, okay, that's pretty hipster, which is, I'm all dressed up for that. But the summary view, a little bit more information. It's like a histogram, obviously, of the selected container. So it has like how many of each bin that you have based on the normalized data. And so you kind of get a quick view of the distribution of like how much of each level you have in the data you're looking at. Entity information, as I said, you can go through and see the more specific things, and it actually facilitates this quick navigation that I was talking about, by you can click on one of these and it'll change the view being visualized in the Mosaic. And support for historical data with this playback bar, and you can you can adjust the delay for presentations or things like that. You can drag it to drag the Mosaic to a different window if you're giving a presentation.
Is there a metric for how many times a file has been modified through commits?
Yeah, I think they, well, probably, like, the metrics are really kind of whatever you can, if you can go through a system and gather a metric like that, then we can visualize that with this. I don't know if they actually do, if it's in the data set, because there's so many, I don't even have time to go through them all. But, or I wouldn't know where to start. But applications at ADB, like I was saying, they use it to look for code hotspots with like the complexity and things like that, to see what they need to say, like, well, this code is really causing us some problems, so why don't we look at it? But also they use it for impact analysis to see, with the developers and the release managers, to see if they should push some updates, like what it will do to the rest of the system. And they use a third-party tool called IMP to provide that data, which is another reason why we need it to be flexible and plug in whatever you want. So, time for the demo. I have it up. It opened. This is MosaiCode. Probably not going to look as good as it should because the resolution on this is kind of not the best. I could probably change it real quick. If you don't mind. If there are any questions for now? Anything?
Won't do too much resolution, unfortunately.
Yeah.
It's also a web app.
You can do it.
It's pretty fun to integrate with GitHub, so you just see it online and be like, oh.
Yeah. Dr. Collard actually did a iPad version of it at one point in time. Dr. Collard is a professor at backend that also works with SCML. Yeah, that's better. Okay. So we kind of have it where you can take an XML or CSV. And this CSV file is the native output of the analysis tool, so that's what we usually do. The thing with CSV files is you don't got the extra XML markup, so the parsing is a little bit slower, but the files are smaller, which is kind of a trade-off. The idea is that we have to actually tell it where the path of each file comes from. So this is the common path attribute. I have it defaulting to the ones that we use. And then we also, whatever attribute defines the version names. And then we had a lot of problems finding prior versions, because if an element's moved, then it's not going to line up the path. So what this does is when it's parsing, it actually goes backwards. So this old file field actually shows where it was moved from. So now parsing through the CSV file, and it's doing that. It's going from version 3 to version 2 to version 1 to grab everything in order, and generating the summary data like mean, median, and standard deviation and all that, and popping us up with our main view. So a typical kind of way to explore this would be, say, you want to select your attribute, look at what's something that's important. Some lines of code. That's a very important attribute. Lines of code tells you a lot about everything. So you see, that's good. You have a nice normal distribution of lines of code among your system. But let's see, what is this one seems to have a lot of big files in it. So double click to drill down, double click again, and then we can actually see each individual file and folder. There's a lot of different things. Multiple coordinated views, you can see here, is something that we tried to build into it. So I clicked into this view on the right-hand side, and then it also connects to this one over there. So if you hold down shift, you can see exactly where it is. So each one of these views is talking amongst themselves. If I click on this, the summary will update. So let's take a look at this attribute here, get us some entity information. Let's see, well, this is just a big file apparently, because the complexity is not too bad, but let's see how the complexity looks over. So click on it, kind of things like that going back and forth. You can like do a search for a random thing, see where it is. Can't really find it, because it's the same entity, but yeah, and then you can look how it changes among versions. That'd be kind of, depends on what the person's looking for, on what attribute they choose or what version they want to look at. Support zooming, and also adjustment of the colors. You can see there some of the red nodes turned yellow, so those are kind of like more on the borderline. Summarize all, more on the borderline between them, so you can kind of get a better idea. So that's about it for the demo. Let's see what else I got here. Future work. Yeah, we're working on getting 2 different attributes so that you don't have just those tiny squares. You can actually add another attribute in for the size of each square, which is proving to be quite challenging to add. Visual Studio plugin, which I don't even want to look at Visual Studio, but eventually we're going to get that going. And then always improving speed and usability. And you saw when I zoomed down to the bottom, it had this line of boxes there. So we want to get it so it automatically zooms to fill everything. And that's about all I have. Any questions, concerns? Did you like it? Did you hate it? You want to buy it?
I do not want to buy it.
Would you steal it?
Yeah, maybe not actually.
No, because is it free?
Huh?
Is it open source?
No, it's not available.
Then I would steal it.
Okay, yeah. That's good, that's good.
So why is it not available?
Because it's not done. Also, it's property of ABD, technically. So,
Our tax dollars are paying for this.
we looked into getting an open source license thing set up, but we haven't really made any progress on that. Kind of hit the back burner.
Can we start?
Oh, question. Are those real glasses?
What?
Are those real glasses?
Wow.
Yes, they are.
Wow,
Really?
Dave.
Yeah.
It's a perfect vision.
I found them, I was cleaning out my storage unit today, and I found them in there, so I decided to wear them.
You live in a store?
Any dynamic visualization. This is one that we saw at this. The whole idea here is these are the different levels of cache in a processor. So it actually visualizes a program while it's running. I think they do matrix multiplication. Right here you got a ring of there are little dots here. They're kind of low quality because of YouTube. But this is the actual main memory, the RAM, and then in here you got like that level 1, level 2 caches, and little pieces of data jump from cache to cache, and you'll see like swipes of like misses as it like has to swap in and out. You just see like a whole line of things going in and out. Pretty cool. I think it's pretty neat. Hard to tell what's going on.
Wait,
but
where can I get that?
this thing?
Yeah.
I don't know.
We present a system for abstract visualization of memory cache behavior, whose purpose is to better understand the behavior of algorithms within a system's cache. Our system provides an abstract view of the underlying hardware and software infrastructure by representing memory as glyphs which move between various levels of the memory hierarchy. This allows students and software engineers to gain valuable insights into the design of their software by means of visual analysis. Here we see a schematic of our system layout. The centermost point represents the system processor. Our display lays out 3 regions, whose locations represent the distance to the processor. The region immediately adjacent to the processor is the level 1 cache, followed by the level 2 cache, and the main memory at the farthest distance. Individual data items are represented by point data glyphs. As a memory location is accessed, its associated glyph moves through the levels of the cache towards the processor. Its size increases and its color flashes. As a memory location becomes stale from lack of use, its data glyph moves further from the processor until it is finally evicted from level 1 to level 2. If the data continues to be unused, it will eventually be evicted from the level 2 cache as well. To better visualize long sequences, the visualization is sped up and path lines are added to summarize time. Our first case study looks at a matrix multiply. Here, a standard matrix multiplication is performed on 16 by 16 matrices. In this case, the size of the matrices makes the data required to calculate a single output entry too large to fit in either the L1 or L2 cache. The result is poor cache performance because the data from the right-hand matrix needs to be read in repeatedly. One simple optimization is to transpose the right-hand matrix. The result is a sweeping action with better caching performance than a standard matrix multiply. Here, each cache line, which is brought into the L1 cache, has all of its elements used before it is evicted. Nevertheless, cache lines from the right-hand matrix will still need to be brought in from main memory repeatedly. A final, well-known optimization for matrix multiply is to use blocking for better cache occupancy. Here we see an example using 4x4 blocks. Surprisingly, the cache performance is not as good as one might expect. The size of our matrix and block configuration causes conflict misses. In this case, some L2 lines lie unused during the processing of certain blocks. With a 12 by 12 matrix and 4 by 4 blocks, the problem is resolved and the caching performance is closer to what one would expect. Here we look at a bubble sort on 96 elements. Despite its n-squared running time, bubble sort has reasonably good caching performance. When the working set is large, the algorithm sweeps through the data using temporally coherent access patterns. As the algorithm approaches completion, cache performance improves significantly as the working set becomes smaller, eventually fitting into L2 and finally L1. As a comparison, we look at cache behavior of merge sort. Aside from the obvious benefit of merge sort's end, log, end runtime, the algorithm displays similar types of cache behavior to bubble sort. Merge sort displays good cache behavior, while the sizes of lists to merge are small enough to fit into cache. As the working set becomes larger, the cache performance decreases, though the merge operation still performs temporally coherent sweeps through the data. The biggest disadvantage of merge sort, as compared to bubble sort, is the need for temporary storage space, which reduces the number of elements that fit in the cache by half. The material point method, or MPM, is an iterative mechanical engineering simulation method in which objects are discretized into collections of points. We show the MPM method as an example of our system's ability to visualize the cache performance of larger working sets in real applications. The MPM method shows good cache behavior as it sweeps through the set of variables. As individual time steps are completed, the system can be observed sweeping through certain variables, resetting their values for the next time step.
I want it. Groovy.
That was good.
Digital jazz.
I think that background track needs to be on every presentation.
Yeah, just like download it and run it on loop. But I'd like to pose a little bit of a question here. Did you think that was a useful visualization? Does it seem like?
It's useful in that it entertains me.
Yeah. That's a big thing in visualization research, is that how do we determine whether or not a visualization is useful?
Well, yeah, I'd say it is. The more, the easy. Oh, I'm sorry. I was just saying is that it's simple to see, the transfer of data between the cache levels, which is what it's trying to accomplish, and it does so very well.
It'd be good when you first educate people on operating system versus architecture.
Yeah. Because I really had no idea what caches were, what they did before I saw that video in the presentation, and I was like, oh, so that's what's going on inside my computer. I hear people talk about it all the time. So I guess it's effective in that respect. But the point I was going for is that nobody knows really how to determine if something is good or not, comparing two different methods. Like MosaiCode, there's ways of visualizing metrics in 1,000 different presentations. You can do scatter plots traditionally, or something even as complex as another one of Dr. Black's papers. He used a city visualization for it with three-dimensional towers coming up. Yeah, that's kind of something to think about.
Have you considered using the city one to represent file systems? So you can recreate the scene from Jurassic Park.
Jurassic Park.
Yes.
That's actually something that
Jurassic Park
was in existence.
Really?
Yeah, it was. I forget what it was called. I googled it a while ago.
So that was actually a Unix system.
It was a terrible prototype tool that some guy developed, and they used it for Jurassic Park.
That's great.
And I'm pretty sure it's not available.
Change directory.
Think about it, moving all these movies, they kind of have to employ some sort of program that's developed these crazy different methods.
Yeah. So yeah, something like that, because it was entertaining, would be usable in a TV show or movie.
Have you considered making a TV show? Have you considered making a TV show in which you will use it?
MosaiCode?
Yeah. You use MosaiCode for solving times.
Working on it. I've employed some script writers in Satterfield to get that going.
Look up on YouTube virus visualization
Is that actually Google Reader?
or computer virus.
It's pretty cool.
Freeform presentation. Which one am I shooting for?
Probably, results seem to be, try the like some
Yeah.
fixed street mile, yeah.
Task Manager Pone's virus looks interesting. That's next.
Oh, this is a. Can you guys see anything? Yeah, probably not.
Start.
There's a lot of different rings and stuff.
Yeah, this is the thing I was thinking about before. This is the actual runtime I think they go through.
Space, the final frontier.
Yeah, that's pretty much what it looks like to me. See, this is a big problem with visualization as well.
Yeah, I think this one.
What does that mean?
Yeah, this one I think was just a strategy for, kind of like a. What's the word? Showing the structure of the code more than anything else.
Really?
Yeah, I'm almost done
So,
already.
probably would
It took
compare,
like 4 hours.
two different types
Yep.
of codes, but let's see.
Yep.
I'll probably do a Google too then.
So, Dan,
Easy.
since your tool is not available, do you know about any visualization tools that are usable by us?
Have you seen
For,
this,
just
style
like
photos
general
of, like,
viz,
sexy
or
and
kind of the same?
all on your computer?
Well, one,
It's very fun.
Really?
What's so
funny about it? Because I set up Cobertura over the summer, and also, not Clover, but something that does the same thing that Clover does, and it had some pretty neat visualizations in it that were useful.
Or are they useful?
Yeah.
was anybody in info viz last semester? Do you remember, what was the tool that we used? One that we,
The tool,
Yeah,
Many
the-
Eyes, I know is one of them.
Many Eyes, yeah. What was the production software that we had to download a trial for?
Oh, the stuff that I didn't do because it didn't work on Ubuntu.
Yeah.
Yeah.
Yeah, that
That's
one, the one that I don't remember.
Course G, it's like source with a G, so that's,
Oh,
it's open source.
Stupid, one thing I wanted to, on Many Eyes is a pretty good one. I think it's a web-based visualization, and you can, it's kind of like a social viz creator.
It's a Java applet.
It's a Java app. And so, you can like share your visualizations and everything, which something, also like this is, the programming language processing, which I think is built on Java as well. It's good for visualization, and they have a whole community. Is this a
I'm actually surprised that found processing.org as the first link
Yeah,
to searching processing.
that's true, yeah.
Not quite sure what course it is. I think it's a software version control for sure.
Oh, really? Yeah, so this looks like a graph-based visualization, which is kind of nice, is it? Maybe I might have it. It's like a Google project. Processing.org, if you want to get into visualization and you know a bit of Java, I'd recommend taking a look at processing. Where's the one that's the community? Open processing, yeah, there we go. So this one's pretty cool, where you can actually share these visualizations that you've made in processing. And like, it doesn't have to just be visualizations, it's just a basic graphic-oriented language. So you can do drawings and stuff like that. But a lot of people, let's see if I can find that. I think it's, maybe it's one out. There we go. I have a friend that does a lot of mathematical based ones. And what's the Java loads, if it does. And you can just kind of like do things like this. I think this this is like visualizing some sort of crazy set morphing fractal thing. I don't know. Like he tried to explain it to me one time, but perhaps Nick Cheats would be able to follow along better
Fractals?
with the explanation. Now, I don't know what it is exactly. What does he say in the description? Is there a description? Oh, Perlin noise.
Oh, Perlin,
That's
yeah.
what it is.
Dr. Rossline probably knows about that.
Well, what?
Perlin noise.
I'm ready.
Okay. Well, it's basically, it's just it's a computerized way of generating things that look like they're from nature and they're kind of random.
Oh.
I think Perlin noise is actually used, I think it's used in Minecraft to generate the terrain.
Oh, really?
Yeah.
That's where I've heard it from. Yeah.
Yeah, so you can do kind of things like this. It's like not very useful. You can make it useful if you want. Ben Fry actually wrote a book. If you want to get more information, this is available on Safari. Called Visualizing Data, and he goes through how to make things with processing to be useful for visualization. I'd recommend checking it out. It's a good book. I've had it checked out from the library for a good 8 months now.
Sonar. I found the tool I was looking for. There's a tool called Sonar that integrates, if you're doing Java development, it integrates like find bugs, Covertura, which does code coverage of your unit tests and all kinds of things. So you can see in one place all your code smells that it found for you and which lines of code are covered by unit tests and which aren't.
Oh, cool.
Yeah.
How does it show that?
It gives bars.
Bars are good.
They're easy to understand.
Yeah. Very intuitive.
And for software engineers who just want to see, okay, 80% of our code is covered, it works.
Yeah.
And you can just drill down through it.
Yeah.
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 If you've never,
Yeah.
Yeah.
you've never used Safari books,
If the yellow.
Yeah.
the camp website, the library
If you
website.
have any, yeah. Well, yeah.
Safari books in Safari.
Research.
You gotta research. Thank you, Kevin.
Safari section.
I always just got to it through Flashlight.
Oh, electronic books, yeah. And then,
Producer
At the
consumer.
bottom.
Safari Tech Books Online has a lot of stuff, and this will log in through the university subscription. So if you're ever looking for anything related to computer science in any way, then they'll probably have it. A lot of textbooks.
Is it all like online? You see it on there?
It's an ebook.
Oh, cool. So you can actually download it?
Yeah.
No, you
So-
can't download
You can't?
Oh, no, you can't download
You
it.
view it in, yeah, you view it in the site.
But as long as you're a student at the university, you can check it out and read it. And
it.
Yes.
As long as you're on campus, you can look at it.
Even off campus.
You can
If
download
you're not on campus, but if you're not even a student.
Yeah, you
it's
can use
kind of
VPN
campus.
for it.
Yeah, oh, yeah.
You can download it if you have the patience to take screenshots of every page and a lot of time on your hands.
They watermark each page
Yeah, so you can just kind of like go through
Okay.
and read it.
with your IP address and the time.
Really?
Yeah,
How?
you can see it.
Where?
I don't know. Dan, scroll around on some pages, it'll just randomly show up.
Show what?
Bam.
The watermark, they leave the watermark on it.
Like all
Now I know.
But I can't see it from this
So
projector.
Kevin, what you're saying is if I'm kidnapped sometime and all I can do is access Safari books, and I know all the where every IP address is, I can find my location.
Yes, yes, that's exactly what I'm saying.
Yep.
Yeah, but they have full books on there. It's not like Google Books where it has pages cut out or anything.
That's because copyright laws are evil.
Yep.
Because the university pays a
Yep.
big sum of money.
Open source
to
and
American dollars
everything.
to provide it.
by the way, if you have an ACM member, you also have access to Safari books through ACM.
I don't think the
And the
student
ACM
memberships
digital library.
give full coverage.
The ACM Digital Library as well.
I think the ACM student memberships don't give full access to the digital library or the books. Yeah.
I was told that I did, I think.
I don't think the $20 membership does at least.
Maybe not.
We like I did deactivate a couple things.
You also get discounted admission to ACM conferences. ACM sponsored events.
Music festival.
I don't know, but
Cheap tickets to the
student
bar.
memberships are generally like $20 to $30 for any sort of organization. I know when we went to BizSoft, it was ICSM was the parent conference, and that's put on by IEEE. So we had a student membership was like $25 for IEEE, and it was actually a $100 discount on the conference registration fee. So I was like, well, you know, why not sign up for a membership and save some money?
Some companies cost them thousands of dollars.
Yeah, ICSM was $500 for the registration, for student registration. I think faculty and presenters were like $900 or something like that. Sometimes, but that's what they make grants for. Any questions on anything related or unrelated to what I've talked about today? Kind of.
Yeah, Safari Books is only available to professional members of ACM.
Okay. But yeah, check it out. Explore visualization. It's very fun. It's an interesting subject.
There's like a whole subset of TechTalks on data visualization and data mining. It's a very extensive field, so.
My coffee's
You
very
know,
important.
she
See that?
is very sensitive about it.